Hey guys, and welcome back to another video on the channel. Today I'm going to be teaching you how to do a U-sub. So a U-sub is used in integration a lot. It's like the reverse chain rule. So if we have, let's just say we had sine of 2x. If we were to differentiate that with respect to x, you would need to apply the chain rule. So differentiate the outside, multiply by the differential of the inside. So it would be 2 cos of 2x, okay? Now, if we were to integrate, we'd have to go back this way. So integrate with respect to x should give me this guy here with a plus c. Now, what if we had to integrate without the 2 there? So we have cos of 2x dx. How do we know that it will be a half? So if I had this set up like this, that's still all good. But if I just had this by itself, I would need a divide by 2 on that side. That would be its answer. But how do you know it's its answer all the time rather than just remembering it? Well, this is where U-sub comes in. So let's consider this example again. So the integral from cos of 2x dx, cos 2x dx, and let's say we don't remember to divide by the 2. What we can do is pretty much identify our inside function. So this is our inside function, and we let that equal u. Okay, so u is 2x. Okay, so now we want to find what a du is. So we want to replace this because we want to integrate with respect to u. So whatever variables here is what you're integrating with respect to. If I were to just sub in u right now, this would be useless at the moment because I'm integrating with respect to x. I need to integrate with respect to u. So the way we do that is we literally differentiate both sides with respect to x. So what we get here is du dx. Differentiate that with respect to x, you get 2. Now, what a lot of people don't know is you can actually break up this differential like a fraction, because all this is saying is change in u with change in x. So I can move my dx up here if I wanted to. So therefore du equals 2 dx. Now, what I'm going to do is try and get dx as the subject of our formula here. So divide by 2. So dx equals du over 2. And that's what we were after. The reason why is because now we can substitute the u into here and the dx into here. So what we get is this new integral here. So when you apply u sub, you're going to get the integral of cos, replace that with u now, and replace the dx with du on 2. So if I clean this up, I can take out the half out the front door. So I have a half the integral of cos of u du. Integral of cos is sine, so we'll have a half sine of u plus c. And we remember our u was 2x, so we have a half sine of 2x plus c. And that's it. So rather than remembering this factor at the front, you can just apply u substitution and you'll get it every single time. Now let's have a go at something like this. So let's say we had x on x squared plus 1 dx. This one is you have to use u sub most of the time. So what we are looking for is pretty much, alright, we know it's going to look kind of like a log, but we're not sure what it is going to be. Because recall, if you integrate 1 on x, you're going to get natural log of x plus c. Okay? So it's kind of got this nature, but it's got this x here and this squared here, and it's just a mess at the moment. So what we're going to do is apply u substitution to it. So you're probably thinking, what one should we pick as our u sub? Well, we've got two options. We've got the top and bottom. If I chose the top, if I differentiate that, I would get just 1, which won't help me a lot. But down here, because of this x squared term, I'm going to get an x factor, which will be helpful to us. So let u equal the denominator. So let u equal x squared plus 1. Then I'm going to find my du. So differentiate both sides with respect to x. Differentiate this, it's going to be 2x. Make dx the subject, so dx equals du on 2x. So all I did was just swap this guy and that guy algebraically to get me this expression here. Okay, so this is what I have. U is x squared plus 1 and dx equals du on 2x. Now I'm going to substitute this guy here, and I'm going to substitute this guy here. So if I do that, this is what I'm going to get. Integral x on u du 2x. And as we can see, the x's cancel and you get, well, take out the half, integral of 1 on u du. And that's really easy to integrate. That's just going to be a half natural log of u plus c. And we remember what our u was, so the answer is a half natural log of x squared plus 1 plus c. Okay? Let's have a go at another example. So, say you had this guy here, e to the 5x dx. My inside function will be this one here. So I'm going to let u equal 5x. Then I'm going to differentiate both sides with respect to x. So I get 5. Then rearrange to make dx the subject. So dx is du on 5. So now I've got u equals 5x and dx equals du on 5. Assign that to our integral. So we'll have the integral of e to the u. Dx is du on 5. Take out the fifth and you get 1/5 integral of e to the u du. If you integrate this, you're just going to get e to the u, so you're going to go 1/5 e to the u plus c. So our answer is 1/5 e to the 5x plus c. So rather than dividing by the differential every time, the u sub can be applied to a situation like this and to every other situation. So rather than remembering that you need this factor here when you integrate, apply u sub every time and it will work. Okay, so that was a quick little video on u substitution. Actually we'll do one more. So I reckon have a go at this one by yourself. So let's go 6x squared So apply u subs to this. So you can pause the video and apply u sub, and let's see how you go. Alright, so I'm going to let this one be my u. So let u equal x to the 3 plus 4x. Differentiate both sides with respect to x, and you're going to get 3x squared plus 4. Okay. Let's add in a plus 1 double, just a slight error with this one, plus 8. Okay, so rearrange it and make dx equal du on 3x squared plus 4. Apply that and you should get this 6x squared plus 8 all on u, and then you have du 3x squared plus 4. You can see this here is exactly double that, so you still have a 2, integral of 1 on u, but the rest of it will cancel, but you'll have a 2 there, du, so you get 2 natural log of u plus c, and then 2 natural log of x cubed plus 4x plus c, and that's it. Sorry for the confusion with that one. I just had to add that plus 8 for it to work. Otherwise, it would have been a bit trickier to do. Okay? But other than that, all good. I hope you enjoyed this video and you learned something.